All right, everybody. So today we are going to get into completing the square day one. Okay. So we're going to fill in some notes here on what is completing the square. And basically, in a nutshell, completing the square is basically making a trinomial that isn't a perfect trinomial a perfect trinomial. So when it says a number of 25 is a perfect square because, all right, it's a perfect square because you can get the square root of 25 is a whole number. So, and I'm writing on my surface here, so we'll see how good this works here. So, yeah, here we go. So the square root of 25 is a whole number times itself. So basically the square root of 25 equals 5, and 5 times 5 equals 25. Now it says x squared is a perfect square because the exponent can be divided by 2 to get a whole number. So, for example, so we know, I'm going to run out of room here. So we know that x times x gives me x squared. So when you root that, you get x, okay? And again, x squared to x to the 6th power is a perfect square because the same thing. The x component can be divided by 2 to get x to the 3rd, okay? So we know that x to the 3rd times x to the 3rd, right? When you multiply like bases, you can add the exponents, gives you x to the 6th. So when you square root x to the 6th, you get x to the 3rd. And if you were to took those x to the 6th and divide it by 2, you get x to the 3rd. Same thing. Because remember, the square root is actually a 1/2 power. So think of 6 times a half. That's another way to look at it. 100a squared is a perfect square because, well, now this gets the best of both worlds. All right? 100 this is um, kind of wrote this backwards here. The 100 is a whole number square root, okay, which is 10. All right, and again, I can take a squared and divide it by 2 to get a to the 1st. All right, so again, a times a gives me a squared, or the square root of a squared gives me a. So again, they're both perfect squares. So a perfect square is created from, this is hard to write with this little pen, but it's a whole number times itself and or an exponent um, that is divided by 2. Because remember, when you take the square root of some number, if you took the square root of a squared, it's a to the 1/2 power, right? So again, you could do that. And you multiply. Okay, that's kind of the example there. So multiply or divided by 2. All right, so let's take a look at and see if these are a perfect square trinomial. All right, well, think of the factors of 256. All right, there's quite a few of them because 256 is a pretty big number. I know 2 works. if you were to figure out what the square root of 56 is, you know what the square root of 56, I'm sorry, 256 is 16. And I know that 16 plus 16 gives me that 32. So we could factor that into two binomials, x plus 16 times x plus 16, or basically get x plus 16 squared. Okay. Now when I get the second one here, if I got a positive number here and a negative number here, usually this is going to be very tough to factor, because a positive times a positive gives me a positive, and a negative times a negative gives me a positive. Now this can be factored into p minus 7 times p minus 1. However, this is not a perfect square. This is not the same binomial times itself twice. These are different binomials, so this is not a perfect square. Okay? And then last but not least, I got to think of two factors that are of 100 when you multiply and give me negative 20. Well, I know 10 times 10 gives me 100, but when I add them together, it gives me positive 20. Well, negative 10 times negative 10 adds up to negative 20. So that's r minus 10 times r minus 10. So these are the same binomials, so this can be written as r minus 10 squared. So these two here are perfect square trinomials. The one in the middle is not. Okay? So if the expression can be factored into the square of a binomial, then you have a perfect square trinomial. Think of a few other perfect square trinomials. Well, I can do x squared plus 6x plus 9, because that's x plus 3 times x plus 3. I can also do x squared minus 6x plus 9, because that's x minus 3 times x minus 3. I can do x squared minus 12x plus 36, because that's x minus 6 times x minus 6. I can also do x squared plus 12x plus 36, because that's x plus 6 squared. X squared minus 14x plus 49, because that's x minus 7 times x minus 7. And again, these are just a few that I'm putting down. But again, it's when I square that number, when I add those two together, I get that middle number. Okay? I can do x squared plus 22x plus 121, because 11 times 11 is 121, and 11x plus 11x is 22x. So lots of different examples here. Here's x squared minus 24x plus 144, which is x minus 12 squared. Okay? So when I get to the bottom here, if I'm trying to figure out the value of c, okay, what number added to itself gives me 14? Well, that's 7, right? And I know that 7 times 7 is 49. So c has to equal 49 here for this to be a perfect square trinomial, which would be g, this would be g plus 7 squared. The next one, I got to think of two numbers when I add them together gives me negative 2, right? So negative 2 plus negative 2 gives me negative 4. When I multiply them together, it gives me a positive 4. So in this one, c would have to be 4 for this to be a perfect square trinomial. And this would be x minus 2 squared. And then the third one, they want us to figure out what b is. Well, I know that 81 times 81, I'm sorry, 9 times 9 is 81, right? But our middle term is negative. So negative 9 times negative 9 still gives me positive 81, but when I add them together, it gives me negative 18. So for this to be a perfect square trinomial, b would have to be negative 18, and this would give me w minus 9 squared. So it says, is there a relationship between B and C? And yes, there is. So that means if given B, C is the square of half the B value. And the other version would be if given C, and obviously you're looking for B, like we did in the third example, B is the square root of the C value. And again, it's paying attention to the signs. All right. So the square root of the C value times 2. So you think about it back up here, right? The square root of 81 was 9. Well, that's negative, right? So there's the negative 9, and negative 9 times 2 is negative 18. Same thing with 7. The square root of 49 is 7. So you take 7 times 2 is, you have to pay attention to the signs. Okay, usually if this is positive and this is negative, all right, that means it's going to be a double negative. If both signs are positive, it's a double positive. All right, let's go to the next page here. This is a short little day as we introduce completing the square. On Wednesday, we will get more in detail to it. So it says any quadratic equation that is not a perfect square trinomial can be turned into one. Okay, so let me erase that one. I don't know how that popped up there, but we need to erase this. Hold on 1 second here. Okay. So we have our equation here. Okay. So the first thing we got to do is take the B value, which in this case is negative 12, divide it by 2. So negative 12 divided by 2, and we're going to square it. Well, I know that negative 12 divided by 2 is negative 6. And when I square negative 6, we get 36. Okay, so that's the first part of it. So we're going to take the 32, and since it's a minus, we're going to add it to both sides. So it says add or subtract. That shouldn't say and. This should be add the C value by moving it to the other side. So if I have x squared minus 12x minus 32 equals it, I'm going to add 32 to both sides. And when I do that, I get x squared minus 12x equals 32. That's when we add 32 to both sides, right? Now we're going to add the solution of our b squared to both sides, which was a plus 36, right? Okay. So now, since I've done that, on the left side, which I'll draw a line under, we can factor our perfect square binomial, right? I have x, I know that 36 is, if you take the square root of it, the square root of 36 is 6. And if I multiply it by 2, I get 12. But the sign is negative. So the square root of 36 should be also negative 6. It can also be negative 6 times negative 6. And when you multiply that by 2, I get negative 12, which is the middle. So our binomial should be x minus 6 squared. And when we add the right side together, I get 68. Okay. All right, once I do so, then we're going to take this and get it into vertex form. And so for me to be able to do that, I have to take the 68 now and subtract it back over. And I get x minus 6 squared minus 68 okay, equals 0. And then it's kind of the opposite, right? When you solve for the roots, we make y equals 0. So now I just turn 0 into y. And now we have this in vertex form. So those are the steps. So let's try a few together. Again, these are trinomials that are not perfect square trinomials. So we have to make them perfect square trinomials. So again, subtract 10 to both sides to start. Oops, hold on, press a little button here. There you go. Very tough to write with this little pen here. Okay, so now what I need to do is I need to figure out, all right, b over 2 squared, and b over 2 is negative 4. Negative 4 squared is 16. All right, so now I'm going to add 16 to both sides. So on the left side, again, I got to think of my factors that when you are perfect squares of 16. Well, the square root of 16 is 4, but 4 times 2 is 8. But also the square root of 16 can be negative 4, because negative 4 times 2 is negative 8. So that is our perfect square binomials. Our minus 4 squared is going to equal 6. Okay? And then to get this in vertex form, I'm going to subtract 6 back over. So I'm going to end up with y equals r minus 4 squared minus 6. And I have it in vertex form. All right, let's try the other one. Now the other one, they already have it on the right side. So here's my b, right? So we take b over 2 and square it. Well, this becomes 1, right? Because 2 over 2 is 1. 1 squared is 1. So when I take, I'm going to add 1 to both sides. The 3 was already over there. I don't have to do it. So now the square root of 1 is 1. And when you take 1 times 2, there's 2. So we have r plus 1 squared equals 4. And then I'm going to subtract 4 back over. So that's gone. And I'll be left with y equals r plus 1 quantity squared minus 4. And there is my answer in vertex form. So again, there is no homework tonight, just these notes, and that was completing the square.